Hello, everyone. This presentation takes us into the project, the Interreg Europe Project Zero CO2, into one of the deliverables of this project during its second semester. And it talks about some of the technology options that are available, which can be considered for buildings in order to reduce their energy consumption and bring the building closer to near zero carbon dioxide. Near zero carbon dioxide buildings is not mandatory in EU directives, but this project has the futuristic idea that eventually EU directives will converge towards near zero carbon dioxide rather than only near zero energy. With me, Damien Gatt, who will be presenting some of these technologies, and hopefully it will be of benefit to you.
And it's important to know that these slides are also available on ResearchGate in the link shown. I am going to skim through this presentation, but those who are more interested can take a closer look at the various technologies by going to the slides on ResearchGate. Basically, I am here looking at the factors that affect energy consumption in a building. These are the 4 factors mainly, 3 internal factors, which are the building services, the type of systems, the plant controls, the operating regime of the building, etc. The building envelope, the size, the shape, the ventilation system, the location of the building, the orientation of the building, etc. The human factors, the comfort requirements of the building, the activity of the building, the access to controls, and so on. And there's also very much one important factor, which is the climate. This is the external factor. Basically, the climate is the reason why some technologies are more suitable for Malta and other technologies are more suitable for more northern or southern countries. Now, let's start first with the factor of comfort, okay? The 6 factors affecting comfort in a building are, as mentioned also by Fengel, are air temperature, the radiant temperature, the air velocity, and the humidity. And there are also personal subjective factors, such as clothing, insulation, and the metabolic heat. In order to combine all these factors together, there's an index that was promoted by Fengel, which at each point tells us whether you are comfortable or not. It is the index has 6 scales from +3 to -3, and the 0 is neutral. In order to be comfort, standard suggests that the PMV has to be between -0.5 and +0.5, which correspond to 10% people percentage discomfort level. Now, one way to see which measures, which passive and active measures are most suitable for Malta is what is called a bioclimatic chart or a psychometric chart. It plots the blue boundary is the temperature and humidity combinations which are comfortable. The other so all the green dots correspond to the outdoor temperatures. The outdoor dots which are bounded by the blue lines are comfortable. We don't need to treat the outside air temperature in order to promote comfort. All other outdoor points which lie outside the blue boundary require to be treated either passively or actively in order for these to be comfortable. And the best measures which are identified by this software, which is climate consulted, are the following, okay? The most important factors are sun shading of windows, okay, in order to avoid direct radiation from glazing heat gained during the summer. In order to promote heat during the winter, in order to be comfortable during the winter, we need internal heat gains, okay? And Dehumidification is very important, okay? In Malta, since the climate is very humid, we don't 0% of humidification, but dehumidification is also important. And one also important measure is to get direct, in winter, is to get direct solar radiation gain via the windows. So it's important that in order to achieve comfort in winter, we need to let out the sun penetrate our glazing. Now, let's look, because before we start looking at the technologies, it's important to be aware of the energy hierarchy required to reach net zero CO2. And we are going to give focus on demand reduction. There is a simple three-step of looking at this: be lean, be clean, and be green. Be lean means one first has to use less energy, reducing demand with sustainable design and construction principles. One example is to use external shading, so as to require less cooling, and also to insulate the roof. The other way is to be clean, that is, supply energy efficiently, such as insulate the hot water piping, use efficient air conditioning, using VRFs or inverters, or also ground source heat pumps. And the third factor is be green. So once you reduce your energy demand, then you use energy efficiency equipment. The last step in the hierarchy is be green. Okay? You use PVs, basically, the photovoltaics. And this was also identified by one of the most famous authors, Kulinski. This is basically the same hierarchy. Such a hierarchy gives the best return on investment and the best energy savings. Now, one can differentiate between passive and active design. Passive design uses solar radiation to optimize the envelope, while active design uses equipment such as fans, pumps to modify the state of the building. One example of passive design is daylighting, while one using appropriate orientation and glazing for the building to promote daylighting, while one type of active design would be electrical lighting. Here are the different passive means of design that are possible. Okay, for Malta, the most important is heat gain by radiation during the winter, and for summer, one has to minimize solar gain, okay, by shading the building, and also promote ventilation. Okay, one can promote ventilation by using courtyards to promote the chimney effect. One can also design the building appropriately to promote wind-induced ventilation and so on. But those are the most important ways to control to make the building, the best ways to make the building comfortable for Malta. First we're going to start at the cooling energy. This is the approach that can be identified in order to reduce the cooling energy requirements. The most important factor is to heat avoidance, tier 1, okay, like using building shading, orientation, vegetation, and also reducing internal heat gains. The second factor is passive cooling, okay, using comfort ventilation from the wind and night purging. And the third tier is use energy efficient equipment for mechanical cooling, when comfort cannot be met by natural means. Let's start with the first factor, which is heat avoidance. The most important technologies for Malta that one can use is shading and spectrally selective glazing. Shading, there are two types of shading, external and internal shading. External shading is much more effective than internal shading, but however it is more expensive. One can see that the typical solar gain factor for external shading is 12%, while for internal shading it is inferior, it is 46%. Okay, these are some of the shading techniques. Overhangs can easily be implemented for south facades. On the east and west facades, the best one can do is limit windows on the east and west facades, because the sun, since the sun is very low at these facades, it's very difficult to control. So best is to avoid glazing on these facades as much as possible. One can also implement movable shading, okay, for east and west facades when minimizing the glazing is not possible. And another very sustainable approach is to use vegetation in order to protect the building from solar gains. A very important technology which is also becoming popular in Malta is the Spectrally selective coatings for glazing. Basically, there are two types over here, low-wick glazing and Spectrally selective glazing. Basically, they function in the same way. Okay, they let visible light you, but you'd use the infrared light penetrating the glazing. Okay, visible light we need it in order to promote daylighting. Okay, but infrared only promotes heat gain inside the building, and for some this is not good. So such glazing technologies allow visible light you, but block the infrared light.
In this respect, we have also seen certain instances where the glazing with solar control coatings have been installed the wrong way. In other words, the coating was put on the inside of the building. In this way, the glazing will work against the whole purpose of the coating itself. Quite often, the solar coating has to be on the outside to limit the penetration of solar radiation into the building.
Then we are going to look at passive cooling, which is the second tier. There are two main strategies for passive cooling. There is ideal comfort ventilation, which is ventilation basically when one opens the windows and feeds the wind passing through his body. Okay, it's called comfort ventilation. And the other one is night purging. Okay, when during summer one opens the windows to let the heat that has been gained during the day in summer, one releases the heat that has been gained in the building during the day. But for Malta, since we have a very hot and humid climate, the best approach is to use comfort ventilation, okay? Because in Malta, we have a low diurnal temperature difference, which makes comfort ventilation more effective than night purging. So ways to promote comfort ventilation is using roof ventilators, such as open stacks, turbines and deflectors. And one can also use a hybrid ventilation solar chimney to enhance the stack effect ventilation, as can be shown in these diagrams. The third approach is energy efficient cooling equipment. Okay, the most famous equipment is the L2L heat pump. Okay, well, for every 1 kilowatt of electrical energy, ideal in winter, in summer, 3 kilowatt hours of heat are lost to the building. Okay, so the heat pumps makes heat from the buildings, transfers heat from the buildings to the outside. And for every 1 kilowatt hour of electricity, it transfers 3 kilowatt hours of heat from inside the building to the outside. The good thing of a heat pump is also it can also operate in reverse mode, both for heating and for cooling. And there are various sources and sinks for heat pumps. The most common is the L2L heat pump, where you have the indoor and outdoor unit where you have heated and cooled by the air outside, okay? But you have also other options, like ground source heat pumps, okay? Well, heat is either lost or gained from the ground. And L2L heat pumps are the vast majority of heat pumps, but there are also ground source heat pumps. Over here, there's a picture shown, okay? Well, the heat is gained or lost to the ground, and this, since the ground has a better stable temperature both in summer and the winter, the heat pump is more efficient. In fact, a reduction of 30 to 70% in electrical consumption over an L2L heat pump was observed. Okay, such ground source L heat pumps are also being studied by Charles at the Institute of Sustainable Energy. Then there are also water to air heat pumps, which are very suitable for hotels near the seaside, okay, and these give an even better performance than ground source heat pumps. Ground source heat pumps and water to air heat pumps are more suitable for non-residential buildings. Now we're going to look at heating, okay. The first style is one has to maximize heat retention by the basic building design, surface area to volume ratio, the envelope values, and so on. The second one is to specify solar techniques such as direct drain, jumper wall, and sun space. And the third is heating equipment, energy efficient mechanical heating. To maximize heat retention, one can use, as an example, one can use opaque thermal insulation. The most famous one is Jeblo, scientifically called expanded polystyrene. There's also another famous technology, XPS, extruded polystyrene. XPS is denser and harder and also has a lower thermal conductivity than EPS, so less thickness can be applied. And emerging technologies which has a very low thermal conductivity is vacuum insulation panels, okay? But they have their own disadvantages as well, such that their border is made of metal, which has a high thermal conductivity, and they also can be easily punched and so on, which increases their thermal conductivity. Then a technology I like and which I see very suitable for retrofitting of buildings is low thermal conductivity insulating plasters, which has also become available locally. And we are now going to look at the passive solar techniques for heating. There are three basic technologies, okay? Direct gain from glazing directly, thermal mass, which has the ability to store heat and release heat during the night, and sun space, which is a space with high direct gains, and heat from the space can be transferred to other interior areas of the building. Then we've got energy efficient heating equipment. There are some examples to mention are the condensing boilers and air-to-water heat pump and the CHP. Okay, the condensing boilers require low return temperatures in order to operate in condensing mode, and so they are good ways to couple them with low temperature thermal units, such as underfloor heating. Then a very interesting technology, which in my opinion should be incentivized, are air-to-source water heat pumps, which are very good for people who don't own a rooftop. They basically have an outdoor unit, which is very similar to the normal L2L heat pumps, and the storage system. And the outdoor unit can easily place in shafts and so on, so it does not require a rooftop. And then another technology which is most important for non-residential buildings is combined heat and power. However, this technology has to be implemented carefully, and one has to study the heating and electric load profile of a building before one considers going for such technology.
One interesting aspect that one has to take care of in winter is, of course, the infiltration into the building. This can come from cracks under doors or in windows, and also from passive vents. Passive vents are openings that in Maltese buildings were traditionally made to ensure a minimum amount of fresh air into each and every room. In winter, this could be a source of undesired cooling effect, and one has to take care how to minimize this aspect.
The last one of the last approaches we're going to discuss is lighting, the approach of how one should design to reach near zero CO2 buildings. The most important aspect is daylight, okay? From a basic building design, using windows glazing, reflective interior finishes and so on. Then one should promote daylighting using techniques such as skylights and light redirecting systems. And the last tile is electrical lighting and controls, okay? Using energy efficient technologies such as LEDs coupled with control systems such as photo cells in order to optimize daylight harvesting. Daylight, okay? We're going to discuss reflective surfaces and internal partitions. The most important aspects for daylight are the orientation and the masking for orientation. Here we can see how a building should be designed in order to promote best daylighting. One should also change partition heights in order not to obstruct lighting. And one should use highly reflective surfaces. One can see the daylight potential for side-lit windows in this diagram when higher reflectances are used. One can also promote daylighting using passive technologies such as stop lighting and light directing systems. Here we are seeing the most common aspects of top lighting. Okay, sawtooth skylight monitors. One has to pay attention to find the optimum combination of heat gain, so that one does not reduce the cooling load, and daylighting promotion. So one has to design the building carefully. Such a nice example is the sawtooth. One can make the glazing look on the north side, while one can promote daylighting using diffuse lighting and leaving heat gains to the minimum. Okay, and skylights also should be translucent. They should not be clear because it would promote a lot of heat. And also they should not occupy more than 5% of the total roof area. One can also look at a very distinct technologies, which is light shelves. Okay, light shelves increase the daylighting potential further away from the window. Okay, and they also reduce glare. And another more innovative technology are light transporting systems. There are a lot of daylight transporting systems available on the market. They are still expensive, but they are becoming more popular. Now we can see some electrical lighting and controls. Okay, the most important technology, which is the most efficient, are LEDs. Okay, they have also a very high lifetime, and they also can be dimmed easily, which is also a very important advantage. And they are not affected by on and off switching, unlike fluorescent. And they also have a very good color rendering. Now, some important electrical controls are the occupancy sensors that can be used for corridors, the photo cells, which can control daylight which can control electrical lighting according to the amount of daylight in the room, and also some very simple but important techniques which are sometimes foreseen are the manual control systems. One should be able to control light manually.
One interesting.
Now we're going to look at the ventilation techniques. Okay, the most important tile is using natural ventilation and hybrid ventilation when tile 2s provide only as much fresh air as required. One should size ducting and insulating accordingly to reduce heat loss and friction in an HVAC system. One should also use energy efficient fans. And tile 3 is using displacement ventilation, using heat recovery ventilation, using demand controlled ventilation by using CO2 sensors, and use free cooling when the outside conditions are favorable. For renewable energy systems, which are the last tile, begin. Okay, we have the most common technologies one can apply are the common roof mounted photovoltaics. The building integrated photovoltaics, they are still not so popular in Malta, but in order to continue increasing the potential of renewable energy, these systems should be further promoted. Then we've got the solar water heating. Okay, the most important technologies which are seen on our rooftops are the tubes and the flat plate collectors, while the unglazed collectors can be used for heating pools. And then we've got a hybrid technology of building integrated PVT systems. Okay, these systems generate both electricity and they can also use heat appel and to reduce the heating loads in winter. Now we also have seen we have done some return of investments, which we see for different measures according to our subjective opinion. Okay, and there are some quick wins. Short-term return on investment of 1 to 3 years. One should upgrade to energy efficient lighting. One should insulate boilers, domestic hot water tanks and pipes. One should properly zone and optimize circulation of space heating and cooling. One should prevent high unnecessary change rate for ventilation and reduce air leakage and remove unnecessary duct pens. One should implement simple lighting controls for corridors. One should implement water-saving faucets. One should carry out energy auditing and proper monitoring. One should train the staff. And one should also reduce high unnecessary internal gains from equipment.
Just a quick comment on the use of LEDs. This type of lighting, although it is very efficient, but the light quality can range from having a considerable amount of UV spectrum in the output light to infrared. So in putting LEDs in different rooms, one has to ensure that in areas where one requires to promote relaxation, the type of LED needs to be of the far infrared emitting type. While for day working, such as in offices, one has to install LEDs that provide a component of UV spectrum. And this, otherwise, if one mixes these types of lights, it could interfere with the mode how people rest, how they sleep. It can affect their sleeping routine.
As medium-term return of investment, one can upgrade to high-efficiency boilers, efficient ventilation systems, possibly including heat recovery. One can, for cooling, and one can use a hybrid ventilation system, update to more efficient solutions for electric space cooling, energy efficiency rating of electrical appliances, energy efficiency motors in HVAC applications, utilize waste heat of HLL, low temperature heating, high temperature cooling using adaptive temp comfort control, photovoltaic assuming government grants and feed-in tariff, solar water heating system if properly designed, planned, managed and maintained. And other medium or long-term return of investment are installation of sun shading devices and installation of Spectrally selective films. Long-term return of investments are windows changing, given that Malta has a very temperate climate, building opaque and transparent insulation, air-to-water heat pumps, given this kind of scenario as is with no grants or feed-in tariff, ground source heat pumps, water-to-well heat pumps, solar-powered absorption chillers, CHPs, wind energy, light transporting systems, and adding skylights for building retrofitting. Thanks for your attention.